So today we're going to create a hovercraft. These are the materials that you're going to need. A glue gun, a balloon, a bottle cap, and lastly, the most important thing, a CD. First, you're going to place your CD flat on table. Get your bottle cap and place it right at the center of the CD to allow the air to flow from the bottle cap down to the bottom of the CD. Once you have that in place, you're going to get your glue gun and basically glue around your CD. And then once it's in place, you can use some form of tape to basically trap some of the air in the center so that the air that comes out flows slowly. Here's one that's already been prepared. So notice how you have your CD, your bottle cap is at the center, and then you've got the glue around the center of the CD to basically connect the cap to the CD. Notice how there is a hole right here that allows the air to flow through from the balloon going down to the CD. So we're going to get our hovercraft and place it flat on the table. We're going to obtain a small piece of tape that we're going to put over the hole of this bottle cap. You want to puncture a small hole through the tape to allow a small amount of air to flow. So once we've gotten that taken care of, we're just going to put this on the bottle cap. So once you've placed the tape on top of your bottle cap, you may now blow into your balloon and then be ready to place it on the top of this bottle cap. Let's check it out. All right, now that we've given our balloon enough air, we're just gonna pinch the bottom part of it and then attach the balloon to the bottle cap of our hovercraft. And there it goes, our hovercraft is moving. You can even play air hockey with it. So the experiment explored Newton's third law of motion, which basically states that for every action there is an equal and opposite reaction. So the force that was coming from the balloon was pushing downwards, which was allowing some space for the hovercraft to basically move up a little and allow it to move around the table. For today's experiment, we're going to create a magnet using simple supplies that you could find at home. The first material you'll need is a screw, copper wire, a battery, and some magnetic items that we can use to test the strength of our magnet. Let's check it out. We're going to get our screw and basically wrap this copper wire around our screw. You do want your wire wrapped around your screw with at least 10 to 12 loops, just like what I have right here. Now notice how my screw has copper wrapped around it, but we've got this green material that is wrapped around the screw. Well, really, the copper wire is considered a conductor, which means that it can pass heat and electricity fast. And this green material that's wrapped around it is some sort of plastic, which is an insulator. The insulator is going to allow us not to burn our hands and basically protect our skin from the heat coming from the wire. Let's check it out. Now that you've got your screw with your wrapped copper wire around it, make sure you have your battery handy and basically connect the battery with the ends of your copper wire. Once you have it in place, you can test the magnet by picking up other magnetic items. And notice how we've picked up some paper clips, and we've also picked up a set of keys. We know that copper is a metal, and metals are great conductors of heat and electricity, which means that metals have electrons that move freely. By placing both ends of our copper wire on a battery, we've allowed what we call a current to flow through the wire. Once that current flows through the wire, it also magnetizes the screw that it's wrapped around in. Once the electrons have flown through the copper, it magnetizes that screw. And once that screw is magnetized, that's how it behaves as a magnet. We hope you enjoyed this homemade magnet experiment, and hopefully you can try making one yourself. Just remember to be careful with the battery because that is going to be a source of electron flow. If you like this video, catch us next time here at Expulsion Science.